3.6 is very, very close to section 3.5, with just maybe a couple little twists to it. But most of the stuff that we talked about on 3.5 that you just finished taking a quiz on is kind of going to be in this right here. So, but we're gonna stress maybe a couple different graphs. What did we really stress before? Like a square root graph, an absolute value graph. Was there anything else in that quiz? Was it just straight lines, right? A linear graph, that kind of stuff. I think you had one of each, didn't you, on that quiz? You had one straight line, you had one absolute value, the v, remember that one, and then you had the square root, and that kind of started at one point and kind of swooshed over, right? All right, so you had those kind. Now, we have talked about these other two, but let's get a little bit more detailed. So we're going to do a squared graph, and we did talk about this the other day, but we're going to play around with this and see what that looks like. Do you remember what the shape of a squared graph is? I think we've said it. What is it? It's a parabola, right? Okay, so this looks like a parabola. Remember what a parabola is? Look, if I just sketch this real quick.
Real big smiley face.
Big smiley face? Okay, you could look at it that way. There's the face. Or what if it was negative? What if it was negative? Then it would be a frowny face. All right. I've never referred to it like that, but I could definitely see where you're coming from with that. All right. So that would be a parabola. We're going to do another one, and we're going to do one, or y equals the inverse graph. We did this when we first started talking about graphs in section 3.5. I believe we did this, but I think we only did it once. And I'll tell you what, we'll hold off on that right now until we do some of this squared graph stuff. Now, here's another thing they're going to do. They are going to actually give you a graph, and this time you're going to have to tell what the equation of that graph is. Okay? So instead of them giving you the equation, you graphing it, they're going to give you the graph, and you're going to figure out what the equation is. Think you can handle something like that? Well, if you know how to graph and to translate it or to move it, shift it to the left and shift it to the right or shift it up and down, if you know all that stuff and what that does to your equation, you should be able to do what we're going to do. Let's go to graph paper. So I've made a graph paper thing right here, and let's put an x and a y axis. I should have put that on there before we started, but it's okay. And let's scooch it down a little bit further. That looks good. And then we'll start another one about right here to about right there. I'll tell you what, let's extend this one over 1. Does that look pretty even? Yeah, that looks pretty good. All right, so what we're going to do is I'm going to put a graph on here. We'll do it in a different color. Let's do it in red. And let's see if you can tell me what the equation of this graph is. Let's start it right here. And then I'm going to put one here. Put one here. Alright, put one here and put one here. Alright, so I'm going to do this in 2 parts just because I'm a little squiggly on this. And then we'll try to curve it up like this. And come on. It's not the most beautiful thing in the world, but you get the idea. Alright? Bet yours doesn't look a whole lot better than that, does it? This was supposed to start. I'll tell you what, let's do this. Let's try this one more time. So it comes here. I'm not making this very smooth, am I? Let's come in from this direction. That looks a little bit better. And then we'll come from this. It already smooths it out a little bit, but I don't know. I think you still have to have some kind of a steady hand, which I don't have that much of, so I'm not a surgeon. Yeah, good thing. That's for sure. All right, so let's take a look at this. And I've given you the graph right here, and you have to tell me what it is. Well, it looks like a parabola, so what's the general equation of a parabola? It's y equals what? X squared, okay? But what did we do to this? Now, if I just had y equals x squared, where would that be? That would be the vertex of that parabola would be right there at the origin, and it would have gone up like this and up like this. Would you agree? All right, but this is not centered, or the vertex is not at the origin. The vertex is right here at this point. So what did we do to it? We took it and we moved it how many places? 1, 2, 3 to the left, and we moved it up 1. So what does that do to my equation if I move it 3 to the left and up 1? That's right. It's plus 3, isn't it? Even though we moved it to the left, and sometimes we think, oh, move it to the left, that's negative. But when we move it left and right, it's actually the opposite sign than we think it's going to be, isn't it? So it's going to be x plus 3. And that goes within my function. Okay, this is a squared function, so it's inside the function. So I'm moving the x. Okay, I'm taking the x, and I'm moving that left or right. I moved it to the left 3 places, which means this is actually going to be a plus 3. Right? It goes the opposite way. And then I moved it up 1. So what do I do to move it up 1?
+1.
Yep, just put a plus 1 on the outside of this. All right, so I moved the x direction inside the function. I moved the y direction outside the function. Right? And that would be your equation. That's your answer right there. Okay, so if I give you a graph like this, that's exactly what the equation of that graph would be. Does that make sense? So if I, let me try to group this together. I'll copy and paste it. Let's make a different color. Okay. And so let's take that same graph and move it right here. What would the equation of this graph be if I moved it here? Let's see, 1, 2, 3, 4, and then 1, 2, 3. So this is y equals x what? Minus 4, good, because we moved it to the right 4 places. And then we moved it down 1, 2, 3, so it's going to be minus 3. So that would be that equation right there. Does that make sense? All right, let's make this another color. Go green this time. And let's see if I can flip it, reflect it. About the, yep, that's what I want. Okay, what if I did this? Let's put this in, I don't know if I can grab it. There we go. Let's put this over here, and I don't know, let's put it right there. Look at that one. Now what did I do? I flipped it, didn't I? So what does that do if I flip it?
Negative.
Makes it a negative out in front. Good. All right, so by flipping the thing, I made it negative. So I put that outside my parentheses. Now, where did I move it? I moved it to the left 1, and I moved it down 2. So if I move it to the left 1, this is going to be x what? Plus 1. You see that? I moved it to the left. It's going to be plus. It's the opposite sign than what you think it's going to be. So I put x plus 1. Put that inside the function. It's a squared function. I put it in here. And then I moved it what? Down 2. So I go minus 2. So that's that function right there. All right? You get the idea, don't you? All right. And I don't think, at least on these homeworks, I don't think they stretch them or make them skinnier. Sometimes it's hard to tell if they, how much they stretched it or made it skinnier. I think all they worry about is translating it. That's what they call it. The translating or shifting it over left and right, up and down. All right, so you look at it, you know it's a parabola, so you know it's a y equals x squared. That's one thing you have to know right off the beginning. You got to know that a parabola is y equals x squared. And then just see where we moved it to. All right, if it's not right here at the origin, if the vertex is not right here at the origin, you're going to have to change some things within your little equation. It's pretty easy, isn't it? All right, let's do, and you have 1, 2, 3, 4 problems on this worksheet that look almost identical to that. Let's go back to this thing. This thing right here, y equals 1 over x. We've done this once before, but let's do it again. Put a little x and y axis there. And let's go with a different color and color this up a little bit. So y equals 1 over x. If we're not really sure exactly what it's going to look like, what's a surefire method? Using one of these, right? What do I call this? This little xy chart. Okay? So let's put some numbers in for x and see what we get. Well, let's put in a 0. How about that? All right, let's put it in a 0. So what's 1 over 0? So if I put a 0 in for x, y is equal to 1 over 0. What's 1 over 0? What's anything over 0?
Non-existent.
Right, it doesn't exist. It's undefined, right? It doesn't exist. So I'm just going to put a little line through it. Does not exist. All right, so over here, if I put a 0 in for x, where am I going to put my dot for y? I'm not going to put it anywhere because it doesn't exist. So I can't put anything up and down here, okay? So that was a little weird, but the other ones aren't too bad. Let's put in a 1, a positive 1. So if I put 1 in for x, I got to figure out what my y is going to be. So it's going to be 1, this first one up here, over 1. What's 1 over 1? It's 1. So if I come over here to 1, I'm going to go up to 1 right there. You with me so far? Okay. I'm going to leave a little blank here because I know what's going to happen here, and I just want to leave some room. I'm going to put a 2 way down here. Is that all right? It's kind of weird looking, but I'll show you why I'm going to do that in a second. What if I put a 2 in for x? So I got to figure out what my y is going to be. So I plug in a 2 for the x. Y is 1 over 2. What's 1 over 2? It's 1/2, right? 0.5 if you want. I'll just write it as a fraction. It's 1/2. This is an inverse function. The other was a squared function, which gives you a parabola. This is an inverse function because it's 1 over the x. So watch what I'm going to do now. When I put in a 2 for x, where am I going to go for my y? I'm only going to go up 1/2. So it doesn't even go all the way up to where the 1 is. It only goes up to 1/2. What if I put in a 3 in for x? What am I going to get? I'm going to get a 1/3. So if I come over here to 3, it gets even smaller, doesn't it? Right there. So watch, the further along I go on the x-axis, what happens to the y? It gets smaller and smaller and smaller. But it's never going to touch that x-axis. Okay? This will get really small. If I put it 100, what if I put 100 in for x? It's going to be 1 over 100, which still is bigger than 0, isn't it? Okay? What if I put in 1,000,000 for x? Then I'm going to get 1 over 1,000,000, or 1/1,000,000th. It's still just a little bit higher than that x-axis. All right? So the further along you go along the x-axis, this keeps going up, but it just goes up by just a very, very, very small amount. All right? Do I just connect those 3 dots? Is that it? Am I done? No, it's not. Okay, let me give you a hint. That was a 1, that was a 2, that was a 3. What I'm going to do now, because here's my graph, and it looks like it swooshes down like this, and it gets really, really close to the x-axis, but never touches it. But what does it do from here this way? Well, I'm going to have to put some numbers in. Right? Now remember, if I put in a 0, it doesn't exist. All right? So let's pick a number somewhere between 0 and 1. So what would be a nice easy number between 0 and 1? How about 1/2? Let's put in 1/2 in for x. Well, let's figure out what the y is. Now remember, this is an inverse function. It takes what you put in for x and it flips it. That's exactly what it does, didn't it? It took a 2 and it flipped it, 1 over 2. Took a 3 and it flipped it, 1 over 3. What if I put in 1/2? What's it going to do to 1/2? It's going to do what? It's going to flip it. So what's the inverse or the reciprocal of 1/2? It's 2. So if I put in a 1/2 in for x, it's 1 over 1/2. 1 over 1/2 is 2. So what does that mean up here? That means when I put in a 1/2 in for x, so if I only go over 1/2, how far up am I going to go? Right here. If I put in 1/2 in for x, how far up am I going to go on the y-axis? I'm going to go to 2. See what it's doing? What if I put in a 1/3?
3.
Then it goes up to 3, right? It's just the inverse of it. So if I go in a 1/3, I'm going to come up here and look what it does. It gets really, really close to the y-axis. But guess what? It's never going to do what? It's never going to touch the y-axis because it can't. Because when I put a 0 in for x, that doesn't exist. So what's my graph look like? It looks like this. It gets really, really close to that y-axis. It comes, hits those points, hits this point, down like this, and it keeps on going, and it gets really, 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 really close to the x-axis, but it never touches, and it never touches here. So you put arrows on both ends. So is that all there is to the inverse function? We were leaving out some pretty important numbers here. I started at 0, then I went positive, didn't I? What numbers have I not put in yet? I haven't put any negative numbers in, have I? So let's put some negative numbers in and see what happens. So this is only half of our graph, of our inverse graph. So the inverse graph is kind of weird looking. All right, so let's put some negative numbers in. Let's put in a -1. How about that? Why did I put that in after the 1? I should have scooted the 1 down and had that stuff in between the 0 and the 1. It doesn't really matter, but now that I looked at it, I'm like, oh, that was kind of dumb. So let's do this. Let's scooch this up a little bit. And let's put some numbers in. Let's put in -1 in for x. Well, what's 1 over -1? It's -1. So if I come over here, to -1 on the x-axis, right, I plugged in a -1. What do I get for the y? I get -1. So I'm going to put a point right here. Everybody with me? Then let's put in a number that's bigger, or that's smaller than -1, like going to the left of it. So there's -1. What's this going to be? That's -1. This is going to be -2. Let's stick a -2 in for that. Now remember what this does. This flips it, doesn't it? It takes the inverse of it. But it also has a negative out in front this time that we didn't have before. So if I flip a 2, I get 1/2. But you still got the negative out in front, so it's -1/2. So if I go to -2, I only go down 1/2. Sorry that dot's right on the 2, but you get the idea. You kind of see what's going on. Do I have to really put any numbers that way anymore? No, because it's going to do this. It's going to curve just like the other one did, and it's going to get really, really close to the x-axis, but we'll never touch it. But now I need some numbers in between -1 and 0. So let's pick a number between -1 and 0. How about -1/2? So if I stick in a -1/2 to this, then I get -2. So -1/2, -2 goes right here, and look what it does. This keeps on going like this. And I don't need to put as many points in this way as I did here, because you kind of got the idea what this is going to look like. Your negative is going to look like the same thing, but look what quadrant you're in. You're in the third quadrant. It kind of looks like that. Same basic look to both of these, isn't it? Now, they're not two separate graphs. It's one graph. Now, sometimes they're going to do this. Remember, it doesn't touch this y-axis. Sometimes they'll put dotted lines where it doesn't touch, like this, and they'll continue the dotted lines all the way down, all the way up. That dotted line right there, it's kind of a funny word. It's called an asymptote. Asymptote. It's kind of hard to say that word with a P in there, but there is a P. Asymptote. All right. What that means is that's the line. It's kind of like a invisible force field or something like that, where you can never touch it. All right. Think of it as a like electrified wire or something, right? So this thing right here can get really, really close to it, super, super close, but it can never touch it, right? It can never touch. And that's what this axis is right there. That's called an asymptote. It's kind of a funny name, but that's what it is. All right, there you go. There's your inverse function. Now I probably could have graphed it on the other one and made it look a little prettier, but you still get the idea here of what's going on. So they're going to ask you to graph these. There's two. Yep, there's two on the worksheet where they ask you to actually graph it. We did talk about it, I think, once before. I'm not really sure. Do you remember seeing this at all? I can't remember if we did this or not. I'm pretty sure we did. I think we might have gone a little quicker on it, but took my time. I've never had you graph it on a homework yet, but this time I will. Okay, you're going to have to graph a couple of these. This can also shift left and right, up and down. I don't think on the worksheet they do that. No, they don't, but it could. All right, it could shift up and down. You could put a negative in front of it. What do you think if it would make it negative? It'd probably take this and do what to it? Probably flip it down here, wouldn't it? And probably take this and flip it up here. All right, that's what a negative might do to it. Does that look like it's flickering? Has it been doing that the whole time? I hope my bulb isn't going bad. Probably is. Still flickering, isn't it? Sorry about that. All right, that's it. So your worksheet just says section 3.6. And that's all I got for you. Okay?